1. Kubernetes Fundamentals and Architecture. 1. What is Kubernetes and why is it used? Answer. Kubernetes is an open-source container orchestration platform that automates the deployment, scaling, and management of containerized applications. It solves the challenges of managing large, distributed applications across multiple servers by providing features like automated patches, self-healing rolling updates, and service discovery. 2. Explain the core components of Kubernetes architecture. Answer. Kubernetes architecture consists of two main parts: control plane, master node, copy server, the front end of the Kubernetes control plane, exposing the Kubernetes API. All communication with the cluster goes through the API server. Each CDD, a highly available, distributed key value store that stores all cluster data, configuration state metadata. Kube scheduler selects a node for newly created pods based on resource requirements, constraints, and policies. Kube controller manager runs controller processes that regulate a cluster's state. For example, node controller, replication controller, endpoints controller, service account, and token controllers. Kubelet an agent that runs on each node in the cluster, ensuring containers are in a pod. It communicates with control plane. Kube proxy, a network proxy that runs on each node, maintaining network rules on the network communication to your pods from your routes side of the cluster. Container runtime, for example, containered cryo Docker. The software responsible for running containers. 3. Why is it the smallest deployable unit? Answer. A pod is the smallest deployable unit in Kubernetes. It represents a single instance of a running process in your cluster. It's the smallest unit because containers within a pod share the same network namespace, IP address, and storage, making them tightly coupled and allowing them to communicate via localhost. 4. What is the relationship between Kubernetes and Docker? Answer. Docker is a containerization platform that enables you to package and run applications in isolated environments called containers. Kubernetes is a container orchestration platform that manages and automates the deployment, scaling, and operation of Docker containers or any other OCI-compliant container runtime across a cluster of machines. Docker builds the house, container. Kubernetes manages the neighborhood, cluster 5. Explain namespaces in Kubernetes. When would you use them? Answer. Namespaces provide a mechanism for isolating groups of resources within a single Kubernetes cluster. They are essentially virtual clusters within a physical cluster. You would use them for resource isolation, separating resources for different teams, projects, or environments. For example, dev, staging, prod. Access control. Applying RBAC policies at a namespace level to restrict user access. Resource quotas. Setting resource limits, CPU, memory, per namespace. 6. What are labels and selectors in Kubernetes? Answer. Labels, key value pairs that are attached to Kubernetes objects. For example, pods, services, deployments. They are used to organize, identify, and categorize objects. Selectors, used to filter objects based on their labels. Services use selectors to identify the pods they should route traffic to, and deployments use them to manage their associated pods. 7. What is a service in Kubernetes? Why is it needed? Answer. A service is an abstraction that defines a logical set of pods and a policy by which to access them. It provides a stable network endpoint, a fixed IP address and DNS name, for a group of pods, even as pods are created, deleted, or rescheduled. This is crucial because pods are ephemeral and their IP addresses can change. 8. Differentiate between cluster IP, node port, and load balancer service types. O answer. Cluster IP. Exposes the service on an internal IP in the cluster. It's only reachable from within the cluster. Default type. Node port. Exposes the service on each node's IP at a static port. The node port makes the service accessible from outside the cluster by node IP, node port. Load balancer. Exposes the service externally using a cloud provider's load balancer. This type automatically provisions a load balancer and routes external traffic to your service. Requires cloud provider integration. External name. Maps the service to a DNS name, not a cluster IP or node port. Used for services external to the cluster. 9. What is a deployment in Kubernetes? O answer. A deployment is a higher-level abstraction that manages the life cycle of pods and replica sets. It provides declarative updates to pods, ensuring that the desired number of replicas are running and facilitating features like rolling updates, rollbacks, and self-healing. 10. Explain the difference between a replica set and a deployment. O answer. Replica set ensures a specified number of identical pod replicas are running at all times. It's a low-level controller primarily used by deployments. Deployment, a higher-level object that manages replica sets. It provides declarative updates to pods and supports features like rolling updates, rollbacks, and versioning, making it the preferred way to manage stateless applications. 11. What is a stateful set and when would you use it? O answer. A stateful set is a workload API object used to manage stateful applications. Unlike deployments, stateful sets provide stable, unique network identifiers. Each pod gets a stable hostname. Stable, persistent storage. Persistent volumes are provisioned for each pod. Ordered, graceful deployment and scaling. Pods are created and terminated in a defined order. Ordered, graceful deletion. Pods are deleted in reverse, ordinal order. You'd use stateful sets for applications requiring persistent storage, stable network identities, or ordered scaling, such as databases, for example, MySQL, PostgreSQL, message queues, for example, Kafka, or other stateful services. 12. What is a daemon set, and when would you use it? O answer. A daemon set ensures that a copy of a pod runs on all or a subset of nodes in a cluster. They are typically used for cluster-level functionalities like logging agents, for example, Luent Day Logstash, monitoring agents, for example, Prometheus Node Exporter, storage daemon, for example, Ceph 13. Explain config maps and secrets. What's the difference? O answer. Config maps used to store non-sensitive configuration data as key value pairs. They allow you to decouple configuration from application code, making it easier to manage and update. Secrets, similar to config maps, but designed for storing sensitive data like passwords, API keys, and tokens. Kubernetes handles secrets more securely by encoding them, base64, and providing mechanisms for secure distribution and access. Difference, sensitivity of data and how they are handled securely. 14. What is Ingress in Kubernetes? How does it differ from a load balancer service? Answer. Ingress, an API object that manages external access to services within the cluster, typically HTTP traffic. It provides features like URL-based routing, name-based virtual hosting, and SLSL. Termination. An ingress resource requires an ingress controller, for example, Nginx ingress controller traffic, to function. Load balancer service provisions a cloud provider's load balancer to expose a service. It works at the TCP/UDP layer. Difference. Ingress operates at layer 7, application layer, and offers more advanced routing rules based on host name and path, while a load balancer service operates at layer 4, transport layer, and provides a simple way to expose a service externally. 15. How does Kubernetes handle storage orchestration? O answer. Kubernetes provides a flexible storage orchestration framework using persistent volume, PV, a cluster-wide resource representing a piece of network storage provisioned by an administrator or dynamically provisioned. Persistent volume claim, PVC, a request for storage by a user, specifying the size and access mode. Kubernetes matches PVCs to available PVCs. Storage class defines different classes of storage, for example, fast, slow, and their provisioner. This allows for dynamic provisioning of PVEs when a PVC requests a specific storage class. 2. Networking in Kubernetes 16. Explain the Kubernetes networking model. O answer. Kubernetes enforces a flat networking model where all pods can communicate with all other pods without NAT. All nodes can communicate with all pods without NAT. The IP that a pod sees itself as is the same IP that others see it as. This model relies on a container network interface, CNI, plugin, for example Calico, Flannel, Cilium, to implement the actual network fabric. 17. How does pod-to-pod communication work within the same node? O answer. Pods on the same node communicate via the CNI bridge. The fee? CNI plugin creates a virtual Ethernet pair for each pod, with one end in fee. Pod's network namespace and the other connected to a bridge on the node. 18. How does pod-to-pod communication work across different nodes? O answer. Pods across different nodes communicate via the overlay network created by the CNI plugin. The CNI plugin encapsulates pod traffic, for example using VSLN IP and routes it between nodes. 19. What are network policies in Kubernetes? When would you use them? O answer. Network policies are Kubernetes resources that define rules for how pods are allowed to communicate with each other and with other network endpoints. They provide network segmentation and security by restricting traffic flow. You'd use them for isolating different application tiers, for example, front-end, back-end, database, restricting access to sensitive services, implementing microsegmentation within your cluster. 20. How does Kubernetes handle DNS for services and pods? O answer. Kubernetes uses an internal DNS service, typically Kubernetes, to provide service discovery. Pods. Each pod gets a DNS record in the form pod IP address .name space pod.cluster .local. Services. Each service gets a DNS record in the form servicing.namespace.svc cluster.local. Headless services also get a records for their individual pods. 3. Deployment and scaling. 21. Describe the process of a rolling update in Kubernetes. O answer. A rolling update gradually updates application instances with a new version without downtime. When you update a deployment, Kubernetes creates new pods with the new image, waits for them to become healthy, and then slowly terminates old pods. This ensures continuous availability during the update. 22. How do you perform a rollback of a deployment? O answer. You can use Kubectl rollout undo deployment. You can also specify a specific revision to roll back to using Torevision. 23. What is horizontal pod autoscaling? HPA, how does it work? O answer. HPA automatically scales the number of pod replicas in a deployment or replica set based on observed CPU utilization, memory utilization, or custom metrics. It periodically checks the metrics and adjusts the replicas field of the target resource. 24. What is vertical pod autoscaling? VPA. O answer. VPA automatically adjusts the CPU and memory requests and limits for containers in a pod based on historical usage. It helps optimize resource allocation and prevent over-provisioning or under-provisioning. Note, VPA is still in beta and has implications for pod rescheduling. 25. What is cluster autoscaler? O answer. Cluster autoscaler automatically adjusts the number of nodes in your Kubernetes cluster based on resource requests and actual usage. If pods cannot be scheduled due to insufficient resources, it adds new nodes. If nodes are underutilized, it removes them. 26. How would you troubleshoot a failed deployment? O answer. 1. Kubectl, get deployments. Check status. 2. Kubectl describe deployment. Check events conditions, replica status. 3. Kubectl get replica assist, check associated replica assets. 4. Kubectl get pods, LO. Check pod status. 5. Kubectl describe podu. Check events, container status, volumes. 6. Kubectl logs. Check application logs. 7. Kubectl exec itima. Bin Asia debug inside the container. 8. Check kubi a preserver and kubi scheduler logs if no pods are scheduling. 9. Check kubelet logs on the node if pods are stuck in a pending state. 27. Explain liveness and readiness probes. Why are they important? O answer. Liveness probe determines if a container is running and healthy. If the liveness probe fails, Kubernetes will restart the container. This prevents deadlocked containers from perpetually consuming resources. Readiness probe determines if a container is ready to serve traffic. If the readiness probe fails, Kubernetes will remove the C. Pod's IP from the service endpoints, preventing traffic from being routed to an unready pod. This ensures no traffic is sent to applications that are still starting up or experiencing issues. O importance. They enable Kubernetes to self-heal and manage application availability and reliability. 28. What is a cron job in Kubernetes? Give an example use case. O answer. A cron job creates jobs on a repeating schedule. They are used for performing scheduled tasks. O example use case. Running a daily database backup, generating weekly reports, or cleaning up old logs. 4. Security and access control. 29. Explain role-based access control. RBAC in Kubernetes. O answer. RBAC is a mechanism that allows you to define who subjects, users, groups, service accounts, can do what, verbs, get, list, create, delete, to which resources, pods, deployment services, in which namespaces, key components, role. Defines permissions within a specific namespace, cluster role. Defines permissions across the entire cluster. Role binding. Grants the permissions defined in a role to a subject within a namespace. Cluster role binding. Grants the permissions defined in a cluster role to a subject across the entire cluster. 30. What are service accounts? How are they used? Answer. Service accounts provide an identity for processes that run in pods. When a pod makes API calls to the Kubernetes API server, it authenticates using the credentials of its service account. They are used for allowing pods to interact with the Kubernetes API, controlling access to resources within the cluster, integrating with external systems that need to authenticate to Kubernetes. 31. How do you secure access to the Kubernetes API server? O answer. Authentication, using client certificates, tokens, or integrated cloud provider authentication. Authorization, RBAC, defining granular permissions, admission controllers, enforcing policies before objects are created or modified. Network policies, restricting network access to the API server, encryption in transit, using TLS for all communication. 32. What are pod security standards, PSS, and why are they important? O answer. PSCs define a set of security best practices for pods in Kubernetes. They are divided into 3 levels. Privileged, unrestricted capabilities used for highly privileged workloads, baseline. Minimally restrictive, prevents known privilege escalations. Restricted, Highly restrictive, enforces hardening best practices. O, they are important for improving the security posture of your cluster by preventing common security vulnerabilities in pods. 5. Monitoring and logging. 33. How do you monitor a Kubernetes cluster? What tools are commonly used? O. Answer. Monitoring a Kubernetes cluster involves collecting metrics, logs, and events. Commonly used tools include Metrics, Prometheus, for scraping metrics, and Grafana, for visualization. Logging, Fluentd, Fluentbit, Logstash, Elasticsearch, Kibana, ElkStack. Tracing, Jaeger, Zipkin. Built-in tools, Kubectl Top, Kubectl Describe. Kubernetes, Dashboard, though often not used in production. Cloud-native solutions, Google Cloud Monitoring, AWS CloudWatch Container Insights, Azure Monitor for Containers. 34. How do you collect logs from applications running in Kubernetes? O. Answer. Standard output error. Applications should write logs to sestiout and stirre. Logging agents. Deploy a logging agent, like Fluentd, Fluentbit, or Logstash, as a daemon set on each node to collect logs from container runtimes and forward them to a centralized logging system, for example, Elasticsearch, cloud logging services. Sidecar containers. For applications that can't write to sdout SDR, a sidecar container can be deployed in the same pod to tail logs from a shared volume and forward them. 35. What is the role of Prometheus in Kubernetes monitoring? O. Answer. Prometheus is a popular open-source monitoring system that scrapes metrics from configured targets, like Kubernetes components, nodes, and applications, and stores them in a time series database. It is often used with Grafana for dashboards and alerts. 6. Advanced topics and troubleshooting scenarios. 36. Describe a scenario where you would use a custom resource definition, CRD, and a custom controller operator. O. Answer. You would use CRDs and operators to extend Kubernetes functionality for managing complex, stateful applications that have specific operational knowledge. O. Scenario. Managing a distributed database like Cassandra or MongoDB. A CRD would define the desired state of your database cluster, for example, number of nodes, version, backup schedule. An operator, controller, would then watch for changes to this CRD, understand the operational complexities of Cassandra, and automate tasks like provisioning new nodes, handling upgrades, performing backups, and recovering from failures. 37. Explain the concept of taints and tolerations. O. Answer. Taints. Applied to nodes to prevent pods from being scheduled on them unless those pods explicitly tolerate the taint. They mark a node as undesirable for scheduling. Tolerations. Applied to pods, allowing them to be scheduled on nodes that have matching taints. They allow, but don't require, a pod to be scheduled on a tainted node. O. Use cases. Dedicated nodes for specific workloads, preventing certain pods from running on unhealthy nodes, isolating critical workloads. 38. What are node affinity and anti-affinity? O. Answer. Node affinity forces pods to be scheduled on nodes with specific labels. It's a pull mechanism where pods attract nodes. Require during scheduling, ignore during execution. Must meet the rule, but ignored if node labels change later. Preferred during scheduling, during execution. Kubernetes tries to meet the rule but doesn't guarantee it. Node and anti-affinity prevents pods from being scheduled on nodes with specific labels, often to spread pods across different nodes for high availability. O. Use cases. Ensuring performance, compliance, or high availability. 39. How would you debug a pod that is stuck in a pending state? O. Answer. 1. Kubectl Describe podu. Check the events section for reasons like insufficient CPU memory, the cluster doesn't have enough resources, node selector, taints, tolerations. The pod has a node selector, or toleration, that doesn't match any available nodes. Volume issues. Persistent volume claim cannot be bound to a persistent volume. Networking issues. CNI plugin not working correctly on nodes. 2. Kubectl get events. Field selector involved object.num. More granular events. 3. Check Kube scheduler logs for scheduling decisions. 4. Check node resources. Kubectl top nodes, if metric server is running. 40. How would you troubleshoot an application that is unreachable from outside the cluster? Answer. 1. Check service type. Is it node port or load balancer? If cluster IP, it's not exposed externally. 2. Verify service endpoints. Kubectl describes service. Ensure it has healthy pods as endpoints. 3. Check pod status. Kubectl get pods. LAP. Are the pods running and healthy? Readiness proves passing. 4. Check Ingress, if used. Kubectl describe Ingress. Verify rules, backend services, and events. 5. Check Ingress controller. Ensure the Ingress controller pods are running and healthy. Check their logs. 6. Network firewall security groups. For node port or load balancer, ensure external firewalls allow traffic to the node ports or the load balancer IP. 7. DNS resolution. If using a custom domain with Ingress, verify DNS records are correctly pointing to the Ingress controller's external IP hostname. 8. Kube proxy. Ensure Kube proxy is running on all nodes and check its logs. 41. What is a Helm chart? Why is it useful? Answer. Helm is the package manager for Kubernetes. A Helm chart is a collection of files that describe a related set of Kubernetes resources. It's useful for packaging, bundling all Kubernetes resources for an application into a single versionable unit. Deployment, easily deploying complex applications with a single command. Templating, parameterizing configurations for different environments. Management, managing releases, upgrades, and rollbacks of applications. 42. How does Kubernetes handle self-healing? Answer. Kubernetes self-healing capabilities include restarting failed containers. Liveness proofs detect unhealthy containers and restart them. Rescheduling pods on failed nodes. If a node goes down, the controller manager detects it and reschedules its pods to healthy nodes. Maintaining desired replicas. Replicasets and deployments ensure the specified number of pod replicas are always running. Rolling back failed deployments. If a new deployment fails, it can automatically roll back to the previous stable version. 43. What is a pod disruption budget, PDB? When would you use it? Answer. A PDB is a Kubernetes API object that specifies the minimum number or percentage of pods that must be available at all times during voluntary disruptions. For example, node drain, cluster upgrade, scaling down. It ensures high availability for critical applications. You'd use it for stateful applications or mission-critical services that require a certain number of replicas to be running. 44. Explain how Kubectl exec works. Answer. Kubectl exec allows you to execute commands inside a container running in a pod. It establishes a secure bidirectional stream, similar to SSH, between your local machine and the container, enabling you to interact with the container's shell or run specific commands. 45. What is GitOps, and how does it relate to Kubernetes? Answer. GitOps is an operational framework that uses Git as the single source of truth for declarative infrastructure and applications. In applications, Kubernetes, this means all desired states of your cluster, Kubernetes manifests, Helm charts, are stored in Git. Changes to the cluster are made by creating pull requests to the Git repository. An automated agent, for example Flux, Argo CD, continuously observes the Git repository and applies any discrepancies to the cluster, ensuring the cluster's actual state matches the desired state in Git. Benefits, audible deployments, faster disaster recovery, improved collaboration, and higher reliability. 7. Real-world scenarios and troubleshooting. 46. Scenario. Your application's pods are constantly restarting. How do you investigate? Answer. 1. Kubectl get pods. Check the restarts column. 2. Kubectl describe podem describe. Look at the events section for clues, for example, killed crash loop backoff, failed liveness readiness proobs. 3. Kubectl logs. Check the application logs for errors or exceptions. 4. Kubectl logs. P. Check logs from the previous container instance if it's restarting. 5. Check resource limits and requests in the pod definition. Is the container running out of memory or CPU? 6. Examine the application code for bugs or misconfigurations. 47. Scenario. You need to deploy a new version of your application with zero downtime. How would you achieve this? Answer. Use a Kubernetes deployment with a rolling update strategy. Ensure your pods have properly configured liveness and readiness proobs. The rolling update strategy will gracefully replace old pods with new ones, ensuring continuous availability. Consider using maxAvailable and maxsurge to control the rollout speed and resource consumption during the update. 48. Scenario. A new application deployment is failing, and the pods are stuck in image pullback off. What's wrong? Answer. Image pullback off indicates that Kubernetes is unable to pull the container image. Common causes. Incorrect image name or tag. Double-check the image name and tag in the pod deployment manifest. Private registry authentication. If using a private registry, ensure image pull secrets are correctly configured in the pod and linked to a secret with valid credentials. Network issues. Node cannot reach the image registry, firewall, DNS proxy. Image doesn't exist. The image might have been deleted from the registry. 49. Scenario. You have a database running as a stateful set and you need to scale it down. What considerations do you need to make? Answer. Stateful sets scale down gracefully by terminating pods in reverse ordinal order. For example, DB2, DB1, DB0. Before scaling down, ensure data integrity. The database is designed for graceful shutdown and data consistency during scale down, for example, by performing graceful shutdowns of database instances. Data migration rebalancing. If the database sharded data, ensure data is rebalanced or migrated off the terminating instances. Persistent volume claims. Understand that scaling down a stateful set does not automatically delete the associated PV keys. You'll need to manually delete them if the data is no longer needed. Quorum. Ensure you don't scale down below the minimum required replicas for your database to maintain quorum and availability. 50. Scenario. You want to ensure that a critical application always has at least 3 pods running, even during node maintenance. How would you configure this? Answer. Implement a pod disruption budget, PDB, for your application with min available 3 or min available 100% if you want all of them. This will tell Kubernetes that it should try to keep at least 3 pods of that application running during voluntary disruptions like Kubectl drain. 51. Scenario. You notice high CPU utilization on one of your worker nodes. How would you investigate and resolve it? Answer. 1. Kubectl top nodes. Identify which node has high CPU. 2. Kubectl describe node. Check resource usage and events. 3. Kubectl top pods, all namespaces. Sort by CPU. Identify which pods on that node are consuming the most CPU. 4. Kubectl logs. Check logs of the high CPU pod for application issues. 5. Kubectl exec. Top. Go inside the container to see process level CPU usage. 6. Resolution. Scale pods. If the application can be scaled horizontally, Increase the replica count of the high CPU pods. Deployment stateful sit. Resource limits requests. Adjust CPU limits and requests for the pods to better fit the workload. Optimize application. Profile. The application for performance bottlenecks. No to autoscaling. If the overall cluster is consistently high on CPU, consider configuring cluster autoscaler to add more nodes. Taints, tolerations, affinity. Use these to ensure critical workloads get dedicated resources or are spread across nodes. 52. Scenario. Your development team wants to deploy a new service, but they need to access a database running in a different namespace. How would you enable this communication securely? Answer. Service discovery. The database service can be accessed using its fully qualified domain name, FQDN. Database service and name database namespace, DSVC cluster.local. Network policies. Implement network policies to explicitly allow ingress traffic from the application's namespace to the database services pods in the database namespace. This ensures only authorized communication is allowed. Service accounts and RBAC. If the application needs to interact with the Kubernetes, a PI, to discover the database, less common for direct database access, ensure the application service account has the necessary RBAC permissions, 8 ecosystem and CNCF projects for 2 years experience, some familiarity expected. 53. What is the Cloud Native Computing Foundation? CNCF. Answer. The CNCF is an open-source foundation that hosts and promotes cloud-native technologies, including Kubernetes, Prometheus, Envoy, Helm, and many others. Its goal is to make cloud-native computing ubiquitous. 54. Briefly explain the purpose of some popular CNCF projects related to Kubernetes, for example, Prometheus, Grafana, Helm, Istio, Envoy, Cilium. Answer. Prometheus, open-source monitoring and alerting toolkit designed for reliability and scalability. Grafana, open-source platform for analytics and interactive visualization, often used with Prometheus to create dashboards. Helm, the package manager for Kubernetes used to define, install, and upgrade complex Kubernetes applications. Istio, an open-source service mesh that provides traffic management, security, and observability for microservices. Envoy, an open-source edge and service proxy designed for cloud-native applications, used as a sidecar proxy and service meshes like Istio. Cilium, a networking and security solution for Kubernetes that uses EBF to provide high-performance networking, security policies, and observability. 55. Have you worked with any CI/CD pipelines for Kubernetes? If so, describe your experience. Answer. Focus on your actual experience here. Example. Yes, I've worked with GitLab CED for deploying applications to Kubernetes. We used a pipeline that involves stages for building Docker images, pushing them to a registry, and then using Helm charts to deploy and update our applications in different environments. Staging, prod. We leveraged kubectl commands within the pipeline scripts for specific tasks like checking deployment status and performing rollbacks. Mention tools like Jenkins, Argo CD, Flux CD, CircleSI, GitHub, Actions, etc. if you have experience. 56. What are some challenges you faced working with Kubernetes in a production environment? Answer. Be honest and show problem-solving skills. Networking complexities. Troubleshooting network policy issues or CNI plugin problems. Resource management. Optimizing CPU memory requests and limits. Dealing with killed pods. Stateful application management. Handling persistent storage and data integrity for databases. Security. Implementing RBAC. Managing secrets. And understanding pod security standards. Debugging. Identifying root causes of issues in a distributed system. Learning curve. The initial complexity of Kubernetes. Upgrades. Performing cluster upgrades with minimal disruption. 9. Deeper dive into Kubernetes concepts. 57. Explain the life cycle of a pod. Answer. A pod goes through several phases. Pending. The pod has been accepted by Kubernetes, but one or more container images have not been created. Running. All containers in the pod have been created, and at least one container is running, or is in the process of starting or restarting. Succeeded. All containers in the pod have terminated successfully, and will not be restarted. Failed. All containers in the pod have terminated, and at least one container has terminated in failure. For example, non-zero exit code, or by system. Unknown. The state of the pod could not be determined. 58. What are init containers, and when are they useful? Answer. Init containers are special containers that run to completion before the main application containers in a pod start. They are useful for node setup checks, performing setup tasks like database migrations, waiting for a service to be ready, or cloning a Git repository. Configuration. Populating configuration files before the main application starts. Permissions. Setting correct file permissions for volumes. Ensuring prerequisites. Guaranteeing that external dependencies are met before the main application runs. 59. Explain resource requests and limits in Kubernetes. Answer. Requests. The minimum amount of resources, CPU and memory, a container requires. The scheduler uses requests to determine which node a pod can run on. Limits. The maximum amount of resources a container can consume. If a container exceeds its memory limit, it will be killed, out of memory killed. If it exceeds its CPU limit, it will be throttled. Importance. Proper configuration of requests and limits is crucial for resource allocation, scheduling efficiency, and preventing resource contention. 60. What is a read-write-many persistent volume access mode, and what storage solutions support it? Answer. Read-write-many allows a volume to be mounted as read-write by many nodes simultaneously. This is typically supported by network file systems, NFS, or distributed file systems, for example CFS, clusters. Cloud providers often offer managed file storage services, for example AUFS, Azure Files, Google File Store, that support this mode. 61. How do you perform application-level load balancing within a Kubernetes cluster without using cloud provider load balancers? Answer. Service. Cluster IP. The default service type provides basic round-robin load balancing among healthy pods. Ingress. For HTTP/HTTPS traffic, an Ingress controller acts as a reverse proxy, distributing traffic based on host names and paths to different services. Service mesh, for example, Istio, Linkerd, provides advanced traffic management features like intelligent routing, canary deployments, A/B testing, circuit breaking, and more granular load balancing policies at the application level. 62. What is the difference between an empty dir volume and a host path volume? When would you use each? Answer. Empty dir. A volume that is created when a pod is first assigned to a node and exists as long as that pod is running on that node. It's initially empty and data is lost when the pod is removed from the node. Use case. Temporary storage for scratch space, caching, or inter-container communication within a pod. Host path. Mounts a file or directory from the host node's file system into a pod. Data persists across pod restarts, but is tied to the specific node. Use case. Accessing node-level data, for example, logs, monitoring agents, or for applications that need to interact directly with the host file system, though generally discouraged for application. Data due to portability and persistence issues. 63. How would you troubleshoot an issue where a service is not routing traffic to any pods? Answer. 1. Kubectl describe service? Check the endpoints field. If it's empty, no pods are matching the services selector. 2. Kubectl get pods, LWE. Verify that pods with the correct labels exist and are in a running state with healthy readiness proofs. 3. Check the target port in the service definition and container port in the pod definition to ensure they match. 4. Verify network connectivity between the pods and the services cluster IP. For example, Kubectl exec into a pod and try to curl the service IP port. 5. Check Kube proxy logs on the node where the service is being accessed for any errors. 64. What is a headless service? When is it used? Answer. A headless service does not have a cluster IP. Instead of acting as a load balancer, it provides direct access to the pod IPs via DNS. When you query the DNS name of a headless service, it returns the IP addresses of the pods selected by the service. Use cases. Stateful applications that need stable network identities for each replica, for example, peer discovery in a distributed database like Cassandra. When you want to control load balancing yourself within your application. 65. Explain tolerations and no deselector in pod scheduling. Answer. No deselector. A simple way to constrain pods to nodes with specific labels. The pod will only be scheduled on nodes that have all the specified labels. It's a hard requirement. Tolerations. Works with taints. A pod with tolerations can be scheduled on a node that has a matching taint. Without the toleration, the pod would not be scheduled on that tainted node. It's about allowing scheduling on tainted nodes, not forcing it. 10 scenario-based questions. For 2 years' experience, focus on practical application. 66. You have a legacy application that requires a specific kernel module to be loaded on the host. How would you deploy this application in Kubernetes? Answer. This is a tricky one as Kubernetes abstracts away the host OS. Option 1, not ideal for production. Use a host path volume to mount the kernel module directory into the pod, and potentially run an init container to load the module, if allowed by security policies. This ties the pod to specific nodes. Option 2, better. Re-architect the application to not require host kernel modules if possible, or deploy it on bare metal VMs outside Kubernetes. Option 3, advanced, specific. If the kernel module is part of a standard distribution and can be enabled, use daemon sets to ensure the module is loaded on all relevant nodes. For more complex scenarios, consider using a Kubernetes operator that can manage node-level configurations. Most practical for a legacy app. Deploy the application on dedicated nodes with the necessary kernel module preloaded, and use no deselector or no deaffinity to schedule the pods on those nodes. And you'll make our wide. Any seniors, and me way, am our viewer? Answer. Containerization. Ensuring all services are properly containerized, Docker files, optimized images. Service decomposition. Breaking down the monolith into manageable, independent microservices. API design. Defining clear API contracts between microservices. Service discovery. Leveraging Kubernetes services for inter-service communication. Configuration management, using config maps and secrets for dynamic configuration. State management, identifying stateful components and using stateful sets or external databases. Networking, designing appropriate network policies for security. Logging and monitoring, implementing centralized logging and monitoring for distributed services. CI/CD pipeline, automating deployments with tools like Helm and GitOps. Scalability, designing services to be horizontally scalable. Resilience, implementing liveness, readiness proofs, retrieves, circuit breakers, potentially with a service mesh. Security, implementing RBAC, pod security standards, and image scanning. 68. You need to restrict network access to a sensitive database pod, allowing only specific application pods to connect to it. How would you achieve this? Answer. Use Kubernetes network policies. 1. Define a network policy in the database's namespace. 2. Use pod selector to target the database pods. 3. Specify ingress rules with from clauses that use pod selector and optionally name a space selector to allow traffic only from the specific application pods. 4. Ensure your CNI plugin supports network policies, for example, Calico, Cilium. 69. How would you handle application configuration that differs between development, staging, and production environments in Kubernetes? Answer. Config maps and secrets. Store environment-specific configuration in separate config maps and secrets. Helm charts. Use Helm charts with values. YAML files. Create separate values. YAML files. For example, values dev YAML, values staging church YAML, values prod YAML for each environment. When deploying with Helm, specify the appropriate values file. Helm install f values prod YAML. Customizer, a native Kubernetes configuration management tool that allows you to customize raw YAML files without templating. You can define a base manifest and then create overlays for each environment to patch specific values. Environment variables. Inject environment-specific values as environment variables into containers. 70. A developer reports that their pod cannot write to its mounted volume. What steps would you take to diagnose this? Answer. 1. Check pod events. Kubectl describe podo for any volume mount errors. 2. Check PVC. PV status, Kubectl get PVC, and Kubectl describe PVC. Then check the associated Kubectl describe PV. Ensure the PVC is bound to a PV and the PV is available. 3. Check storage class, if dynamic provisioning is used. Ensure that the storage class is correctly defined and the provisioner is working. 4. Check underlying storage. Verify the actual storage, for example, NFS server cloud disk, is healthy and accessible from the node. 5. Check node logs. On the node where the pod is running, check kubelet logs for volume mounting issues. 6. Permissions within the container. Kubectl exec, its lsld path to mount. Check the permissions of the mounted directory inside the container. The application might not have write permissions. You might need to adjust the security context in the pod definition, for example, fs group, runasuser, Zelinux aparmor on host. If present, these security modules on the node might be preventing access. 11. Advanced Kubernetes Concepts 71. What is an admission controller in Kubernetes? Give an example. Answer. Admission controllers are plugins that intercept requests to the Kubernetes API server after authentication and authorization, but before the object is persisted in ECTD. They can mutate, change, or validate requests. Example. Limit Ranger. Enforces resource limits on pods within a namespace, resource quota. Ensures that namespaces don't exceed their allocated resource quotas. Pod security policy, deprecated, replaced by SES, used to enforce security policies on pods. Mutating GADmission webhook, validating GADmission webhook. Allows you to define custom admission controllers using webhooks. 72. How do you manage certificates and TLS in Kubernetes? Answer. Kubernetes secrets. You can store TLS certificates as Kubernetes secrets of type Kubernetes secrets TLS Ingress resources can use these TLS secrets to terminate SSL TLS at the Ingress controller. Cert Manager, a popular open-source tool that automates the issuance and renewal of TLS certificates from various issuing sources, for example. Let's Encrypt within Kubernetes. It integrates with Ingress and manages TLS secrets. Service Mesh, for example, Istio. Service meshes can manage MTLs between services, providing strong identity and encryption. 73. Explain Kubernetes operators in more detail. What problems do they solve? Answer. Kubernetes operators are a method of packaging, deploying, and managing a Kubernetes application. They extend the Kubernetes API to manage complex stateful applications. An operator is essentially a custom controller that understands the domain-specific knowledge of an application, like a database or a message queue, and automates its operational tasks. Problems they solve. Automating Day 2 operations for complex applications, including deployment and upgrades, scaling backup and restore failure recovery cluster, rebalancing. Applying security patches, handling application-specific configurations. 74. What is kubeconfig and how is it used? Answer. Kubeconfig is a YAML file that contains information about your Kubernetes clusters, users, and contexts. It allows Kubeco and other Kubernetes clients to connect to and authenticate with different Kubernetes clusters. It typically resides at each kubeconfig. 75. How does Kubernetes handle garbage collection? Answer. Kubernetes performs garbage collection to clean up resources that are no longer needed. This includes finished pods jobs, deleting pods associated with completed jobs, orphaned objects, deleting objects that are no longer referenced by their owners, for example, a replicacit deleting pods that no longer match its selector. Unused images and containers. Kubelet regularly cleans up old images and containers on the nodes. Kube Controller Manager contains a garbage collector that cleans up various objects. 76. What is a multi-cluster Kubernetes setup? Why would you need one? Answer. A multi-cluster Kubernetes setup involves managing multiple independent Kubernetes clusters. Reasons for using it. High availability, disaster recovery. Distributing workloads across different geographical regions or cloud providers to ensure business continuity. Geographical proximity latency. Deploying applications closer to users in different regions. Regulatory compliance. Data sovereignty. Meeting data residency requirements. Isolation. Providing strong isolation for different teams or sensitive workloads. Hybrid cloud, running workloads across on-premise and cloud environments. Resource limits, overcoming the scaling limits of a single cluster. 77. What is etcd in Kubernetes? What are its key characteristics? Answer. etcd is a distributed, consistent, and highly available key-value store used by Kubernetes as its primary data store. It stores all cluster state, configuration data, and metadata, for example, pod definitions, service definitions, config maps, secrets. Key characteristics. Consistency. Uses the Raft consensus algorithm to ensure data consistency across all members. High availability. Designed to be highly available with multiple instances. Distributed. Can run across multiple machines. Key value store. Simple API for storing and retrieving data. Watches allows clients to watch for changes to keys, enabling Kubernetes components to react to state changes. 78. How does the Kubernetes scheduler work? What factors does it consider? Answer. The Kube scheduler is responsible for assigning newly created pods to available nodes. It considers various factors during the scheduling process. Resource requirements. CPU, memory, GPU, etc. requested by the pod. Node capacity, available resources on each node. Node selectors, taints, tolerations, constraints defined on pods and nodes. Node affinity, anti-affinity. Preferences for scheduling pods on specific nodes or avoiding certain nodes. Pod affinity, anti-affinity. Preferences for locating or separating pods from other pods. Quality of service classes, ensuring critical pods get priority. Volume requirements. Availability of suitable persistent volumes. Port conflicts. Avoiding port conflicts on a node. 12. Miscellaneous and best practices 79. What are some best practices for writing Docker files for Kubernetes applications? Answer. Use a minimal base image, for example, Alpine Distroless, to reduce image size and attack surface. Multi-stage builds. Separate build dependencies from runtime dependencies to create smaller final images. Cache layers effectively. Place frequently changing instructions later in the Docker file. Don't run as root. Use user instruction to run as a non-root user. Copy only necessary files. Use Docker ignore to exclude irrelevant files. Expose ports. Use expose instruction. CMD entry point. Define how the application starts. Environment variables. Use for dynamic configuration. Scan images for vulnerabilities. Integrate image scanning into CNCF. 80. How do you secure your Kubernetes cluster at the image level? Answer. Image scanning. Use tools, for example, Trivy, Claire, Anchor, to scan container images for known vulnerabilities. Trusted registries. Use private, trusted container registries. Image signing and verification. Ensure images come from trusted sources and haven't been tampered with. Least privilege. Build images with minimal necessary privileges. 81. What is the significance of the target port and port fields in a Kubernetes service? Answer. Port the port that the service itself exposes within the cluster. Other services or external clients will connect to this port. Target port. The port on the pod that the service will forward traffic to. This is the port your application within the container is listening on. Significance. Port allows the service to have a stable external port, while target port allows flexibility in how the application inside the pod is configured, decoupling the service port from the actual container port. 82. How do you effectively manage secrets in Kubernetes? Answer. Kubernetes secrets. For storing sensitive data, avoid storing secrets in Git. Never commit plain text secrets to version control. External secret management. Integrate with external secret management systems, for example, HashiCorp Vault, AWS Secrets Manager, Azure Key Vault, Google Secret Manager, using tools like External Secrets Operator or Secret Store CSI Driver. RBAC. Restrict access to secrets using RBAC policies. Encryption at rest and in transit. Ensure etctd is encrypted and all communication is TLLs encrypted. Rotate secrets regularly. Pod security standards. Apply PSS to restrict how pods can access secrets. 83. What is Kube proxy and what are its modes of operation? Answer. Kube proxy is a network proxy that runs on each node in the cluster. It's responsible for implementing the Kubernetes service abstraction by maintaining network rules on nodes and enabling network communication to pods from inside or outside of the cluster. Modes of operation. Iptables. Default. Uses iptables rules to perform load balancing and network address translation. NAT. Efficient for a large number of services. IPVs. Uses IP Virtual Server, IPVS, for load balancing, which offers better performance for high-traffic services. User space. Deprecated. The oldest and slowest mode, which involves Kube proxy acting as a proxy in user space. 84. Explain the concept of immutable fields in Kubernetes API objects. Answer. Certain fields in Kubernetes API objects are immutable after creation. This means once the object is created, you cannot change the value of these fields directly. If you need to change an immutable field, you typically have to delete and recreate the object, for example, changing the selector on a service or the volume amounts on a pod. This is done to maintain consistency and prevent unexpected behavior. 85. What is kubectl drain used for? Oh, answer. Kubectl drain is used to gracefully evict all pods from a node, preparing it for maintenance. For example, kernel upgrade, hardware replacement. It marks the node as unschedulable, and then evicts pods, respecting any pod disruption budgets, PDBS. 86. How would you troubleshoot network latency issues between pods in a Kubernetes cluster? Oh, answer. 1. Identify affected pod services. Is it all traffic or specific services? 2. Check CNI plugin. Verify the health and logs of your CNI plugin, for example, Calico Flannel. Are there any errors or warnings? 3. Node network health. Check network interface statistics, CPU utilization, and general network performance on the affected nodes. 4. Underlying network infrastructure. Is there any latency at the host or cloud provider network level? 5. Service mesh, if applicable. If using a service mesh, check its components and configuration for any issues. Type for netperf. Deploy temporary pods with network benchmarking tools to measure latency and bandwidth between them. 7. TCP dump. Use kubectl debug or kubectl exec to run TCP dump inside pods to inspect network traffic. 8. DNS resolution. Is DNS lookup adding latency? 9. Application issues. Is the latency caused by the application itself? For example, inefficient database queries, excessive logging. 87. What are press-stop hooks and post-start hooks in a container lifecycle? Oh, answer. Press-stop hook, executed immediately before a container is terminated due to an API request, or a management event, for example, graceful shutdown, resource contention. It's a blocking call, meaning the container will not be terminated until the hook completes. Useful for graceful shutdowns, flushing logs, or completing in-flight requests. Post-start hook, executed immediately after a container is created. It's a non-blocking call. Useful for initial setup tasks that need to run after the container starts, but before the main application logic takes over. For example, registering with a service registry. 88. How does Kubernetes handle resource limits and requests on a pod with multiple containers? Oh, answer. Resource requests and limits are defined per container within a pod. The scheduler sums up the requests of all containers in a pod to find a node with sufficient aggregate resources. Limits are also applied per container. If one container exceeds its limit, only that specific container is affected. Throttled or killed, not the entire pod. 89. What is a mutating webhook and a validating webhook? Oh, answer. These are types of admission webhooks that allow you to extend the Kubernetes API with custom logic. Mutating admission webhook can modify or mutate the objects before they are stored in etcd. For example, injecting sidecar containers, adding labels, or setting default values. Validating admission webhook can only validate requests and either allow or deny them. It cannot change the objects. For example, enforcing specific security policies or preventing certain configurations. 90. Explain the concept of volume acclaim templates in stateful sits. Oh, answer. Volume acclaim templates are used in stateful sits to automatically provision persistent volume acclaims for each replica of the stateful sit. Each pod managed by the stateful sit will get its own unique PVC based on the template. This ensures that each stateful pod has its own dedicated, persistent storage. 91. What is the difference between a job and a cron job? Oh, answer. Job creates one or more pods and ensures that a specified number of them successfully terminate. Jobs are used for batch processing or one-off tasks. Cron job manages jobs on a repeating time-based schedule, like cron on a Linux system. It creates job objects at specified intervals. 92. How can you ensure high availability of the Kubernetes control plane? O answer. Multiple master nodes. Run multiple Kubi observer instances behind a load balancer. Distributed etctd. Run etctd in a highly available, clustered configuration, for example, 3 or 5 members. Redundant controllers schedulers. Kube Controller Manager and Kube Scheduler can be run as multiple instances, with only one active at a time. Leader election. Backup and restore. Regularly backup etctd data. Cloud Provider Managed Services. Utilize Managed Kubernetes Services, EKE, AKS, where the cloud provider manages control plane Ha-93. What is Kubi-Adem? O answer. Kubi-Adem is a tool that helps you bootstrap a minimum viable Kubernetes cluster. It handles the provisioning of control plane components, certificates, and setting up worker nodes to join the cluster. It's not a complete cluster lifecycle manager, but a good starting point for self-managed clusters. 94. Describe a situation where you would use a service account and a cluster role binding together. O answer. Scenario. You have an application running in a pod that needs to list all nodes in the cluster for monitoring purposes. Solution. 1. Create a service account for your application pod. 2. Create a cluster role that defines permissions to get and list the node's resource. 3. Create a cluster role binding that binds this cluster role to your service account. By using a cluster role binding, you grant the service account permissions across the entire cluster, allowing it to see all nodes, regardless of the namespace the application pod runs in. 95. What is kubectl diff? O answer. Kubectl diff shows a diff between the current live configuration of a Kubernetes object and a potential new configuration from a local file. It's a useful tool for previewing changes before applying them, helping to prevent unintended modifications. 96. How would you secure a Kubernetes cluster from a network perspective, beyond network policies? O answer. Firewalls, security groups. Configure network firewalls, for example, cloud provider security groups, to restrict ingress-egress traffic to from nodes and control plane components. Private endpoints for a PI server. Access the Kubernetes API server only through private network endpoints if available. VPC peering. Connect Kubernetes clusters to other private networks. Egress network policies. Control outbound traffic from pods. Service mesh. Implement MTLs and granular traffic control. IDS-IPS. Deploy intrusion detection prevention systems at the network edge. 97. What is the Container Runtime Interface, CRI? O answer. CRI is a plugin interface that enables Kubernetes to use different container runtimes, like containered, CRI-O, Docker's Dockershim, now deprecated, to run containers. It provides a gRPC API for the kubelet to interact with the container runtime. This abstraction allows Kubernetes to be independent of the specific container runtime used. 98. How would you implement blue-green deployments in Kubernetes? O answer. 1. 2 deployments. Have 2 separate deployments. Blue, current version, and green, new version, each with its own set of pods. 2. Service. A single Kubernetes service points to the blue deployment. 3. Switch traffic. To switch to green, update the services selector to point to the green deployment's labels. 4. Rollback. If issues arise with green, simply revert the services selector back to blue. This approach offers zero downtime and an immediate rollback capability, but it doubles resource consumption during the switch. 99. How would you implement canary deployments in Kubernetes? O answer. 1. 2 deployments. One for the stable version, main, and another for the canary, new version. 2. Ingress service mesh. Use an Ingress controller or a service mesh, for example, Istio linkered, to manage traffic routing. 3. Gradual traffic shifting. Configure the Ingress service mesh to gradually shift a small percentage of traffic, for example 5, 10%, to the Canary deployment. 4. Monitoring. Closely monitor metrics, errors, latency, performance for the Canary version. 5. Increase traffic rollout. If the Canary performs well, gradually increase the traffic to the Canary until 100%. Then the old stable deployment can be scaled down and removed. 6. Rollback. If issues are detected, immediately revert the traffic split to 0% to the Canary, 100. What is the Kubernetes command? When would you use it? Answer. Kubernetes is a beta command in Kubernetes, as of recent versions, that allows you to create an ephemeral debug container in an existing pod or create a new debug pod from an existing pod, or node. Use cases. Troubleshooting running pods. Attack a debugger or run diagnostic tools without restarting the main application container. Inspecting a crash looping container. Get a shell into a container that's constantly restarting. Debugging nodes. Create a debug pod on a specific node to inspect its file system or processes. Running network diagnostics. Use tools like TCP dump inside a debug container.